Hey folks, we'll be starting up here in just a few minutes.
Can you hear me, Brian?
Yes, sir.
Did I figure this out?
Yeah, no problem. We still got 1 minute.
Hey Scott,
What's up?
if vendor insert logo here. Where's your vendor logo?
You gonna make me one?
Hey, we told you we were gonna come in here and harass you.
I'm not a vendor, so.
Well, I guess our vendor sponsors for this session, at least, are JDation and Cool Tees Custom Apparel. Okay, let's go ahead and get started. So some entry information. If you haven't already, please do change the name of your login so that it has your ID number in it. It looks like most of you do have your number from your VCS ID. There's a handful of you that do not. Those of you who do not will not be eligible for the raffle at the end of the presentation. So what we do is we look for the attendees during the course of the presentation and then do a roll up at the end, see who those folks who are actually still on, and we'll run the raffle at the end. So if you don't have that number, you won't be able to be entered into the raffle. So make sure you do change your name, and if you should have the privileges to be able to do that. All right. So introductions, Scott Hanson is going to be doing a presentation today on controller options. Scott is an electrical engineer and he's been helping out to develop X-Lights for the last 3 years, as well as several other contributions to the community. And let's see, also, if you have any questions, ask that you put those in chat, and then Scott will review those at the end of the session so he can keep pace over his presentation, and then we'll review at the end. There will be a little bit of time. And as I mentioned, the raffle is at the end, so do hang around. If you're not here, you're not eligible to win. You have to be present to win, as the presenters in the first session had mentioned. We do also ask that you keep your audio muted and don't attempt to turn on your video, because we're sharing this session via YouTube right now and recording. So let's go ahead and kick it off for Scott.
Okay, thank you very much, Brian. Can everyone hear me? I didn't screw up or anything this morning. So I just want to go over some of the popular controllers out there. Let's go over kind of their pros and cons of them, things you can do with them, and describe them in a little bit of detail. If you want more information, there's kind of more, there's going to be sessions more specifically on each controller type if you're interested in. So this is just kind of a general overview. There'll be more information in the more detailed sessions later in the day. So I just want to go over a quick overview, kind of things you need to think about when picking a controller, the most common types of controllers, some kind of common features of most controllers, how well they integrate with X-Lights, and then we'll just kind of do an overview of some of the more popular controllers. So when deciding how to pick a controller, I think the most critical thing you need to think about is your show layout. And you need to think about where you're going to place your controller. And you also want to think about maybe what's next year's show layout going to be. Like my first year, I got a small controller. And then my second year, I ended up buying 4 more. So because I had such a limiting capacity my first year with the controller I selected. So you may want to think about getting a controller that has that expandability that can, help you in the future. You want to think about the features, the abilities of each controller. If you plan on using your controller in a boat or something where you need standalone mode, that may be something you want to have. If you just plan on always running it from Xschedule or FPP, maybe that is kind of a not important feature. Something else you want to think about is like your technical ability. So do you want to try to build a controller? Do you want to go the DIY route, or are you okay with just, spending the cash and building or buying one off the shelf? And some controllers also are a little bit more complicated from a software side. So there's some thought into that. You need to think about what you're kind of capable or what you want to deal with. Some of them give you more headaches. And then of course, the last thing is the price of the controllers. So I talk about show layout. You want to think about, is your show going to be expansive? Like, are you going to do something that's really large? Or are you going to have a small show, like you have 1,000 square foot house, it's going to be really pixel packed? The thing that you got to think about is, if you have a large pixel count prop, like a Megatree, a Matrix, that's a pretty good location to put a controller with a lot of outputs. And with the kind of advent of these now mega spinners type props that have like 600 pixels in them, you need to think about how many you're going to have of those and where you're going to place them. And you also need to think where to place the like how far your props are going to be from your controller. Like if you're going to plug in a controller into a prop, locally the data only goes about 20 to 30 feet. So you need to be within that range unless you start getting to differential receivers, which we'll talk about in a little bit later. So I'm just going to go over some of the features and the common Pixel controllers. So most controllers out there, they support one of these kind of 3 main protocols, or 4. E131 is probably the most popular. It's a real industry standard. It's sometimes referred to as streaming DMX. It's basically DMX over Ethernet. There's E131, which is an open source protocol, and then you have ArtNet, which is more of a proprietary license protocol. They're real similar, and most controllers support that kind of out of the box. There's a newer standard that's a little bit more efficient. It's called DDP, and it's a little less common in the industry, and not all controllers support it, but some of the newer, more modern ones do, like the HinksPix and all the FPP-based ones, and the ESP Pixel Stick and the Minion. And then there's the ZCPP, Zero Config Pixel Protocol. That was kind of developed by the X-Lights developers, and it's kind of got limited support right now. It's only really supported on the Falcons and if you're using like X-Lights Xschedule. So when you're like looking at controllers, kind of the most common style controller out there normally has what I call local pixel outputs. So when you purchase a controller, the kind of standard output numbers, there's some as low as 4 or 2, 8, 16, and up to like 32. And these outputs they'll have a fused power, so you can power the string as well off of the port. But when you're going off of these local ports, you can only get about 20 to 30 feet to the first pixel in your prop. Most boards by default will support 5 and 12 volt pixels, and even some of the controllers also support 24 volt pixels. But you'll have to refer to the manual of that specific controller to see if it supports 24. So the newer style of controller that's gained popularity in the last couple of years is what we call these differential or long range output controllers. And how they work is each RJ45 connector, which is the black connector, it supports 4 outputs that then go to a differential receiver card, which is like what the Falcon one is on the far right. And these are designed because of the limitations of like data to the first pixel. You can go long distances, like 300 feet or more, from a controller to one of these long range receiver cards. Most of them only support 3-wire pixel protocols, which is like your WS2811, 2812, which is the standard that most people use. And the thing is, they can be a little bit more expensive in the long run because for every output, you have to get one of these differential receivers, and that starts to add up after a while. So that's kind of the debate if you want to do local or remote. And some of the controllers, like if you look at the picture on the left, that's a F8 PB. It has 3 remote ports, so you can do some long range you can do long range. You have some long range ports to do some props, and then you also have local. So if you want to put it like under a mega tree for your local stuff, you can do that. But then you could also have maybe a roof line or something else farther away. And then there's controllers like the 682, which is all local, and then like the F48, which is all remote. So a lot of the Pixel controllers, they have DMX or a serial output. So like on the F16, there's actually technically 4, but most people only use 2. The Hinks Pix there only has 1, and then the Culp boards, some of them have 1 to 2 to 4. And these are good for controlling like lower boxes that you can put in DMX mode, or if you have a Renard controller that you can put in DMX mode, you can control that. And for even more stuff like floods, moving heads, fog machines, anything that's DMX, you can kind of drive off these ports, and the controller itself will be used as a bridge from like E131 or DDP to DMX 512. So what I was kind of talking about earlier is expandability. Like the F16, the Culp boards, and the Hinks Pix, they all support like you can add more expansion cards to them. So by default, like an F16 only has 16 outputs. You can then add 2 more expansion cards on there and get the full 48 outputs. And this is similar to how like the PB8 from Culp is. It only has 8 plus the differential ports. Well, it also has it has an expansion slot, so you can do another 16 outputs. And those 16 outputs can be like local ports, or they can be these differential outputs. So you can do 4 more differential ports. And the Hinks Pix and the Alpha Pix have a similar system where you can plug in additional local ports. They call them SPI cards or differential receiver cards. So you can expand some controllers up to 48 outputs with these add-on cards. The more advanced controllers kind of support this standalone mode. And the Hinks Pix and the Falcon, it's SD card based, where you basically have to put the SD card in your computer, load your sequences on it, and the controller can then run in a standalone mode by itself. Most of them also have a real-time clock, so you can put a schedule in there, and it'll start at like 5 p.m. The FPP-based controllers are a little bit more advanced. They're actually running a full Linux OS on them. So you can actually upload your sequences over Ethernet or Wi-Fi, or you can use like a USB drive, and you can just play sequences in a standalone mode. To get audio out of them, like the Hinks Pix has an audio output jack by default. The newer cult boards have audio output jacks, but the cult boards or the FPP based, you can also use like a USB to audio adapter to get audio. And the Falcon has an add-on card that you have to get from Pixel controllers that lets you do audio. So I just want to go over some of the popular controllers. This is kind of my opinion, what's popular. Like if you sit in the Zoom room, these are kind of the ones you see a lot of people using. So the Falcon controller is probably by far the most common. It can do up to like 96 universes. It also has ZCPP support, like I said before. The F16 by default only has 16 local outports, but using those expandability, those cards, you can do up to 48. If you get the little lesser known Falcon controller, the F4, it actually has 4 local outputs, but with a expansion board, there's a custom one for that. It can actually do 12 outputs, and so per output it can then do 1020. So on the F16, it's 1020 pixels per output, but there's a little caveat on that. When you start getting to expansion boards, it has to be divvied up, so it's a little bit less. But like with the F4, when you put the expansion boards on that, it's actually 1000 pixels per all 12 outputs. Similarly, it has 4 DMX outputs on the F16 and the F48. By default, the bottom 2 ports, if you can kind of see, those break them out exclusively, so that would be DMX 2 and 3. And then the top one has all 4, but you don't want to use that by itself. You kind of want to break them out. You have to make a special cable. And they also support this newer smart/dumb receivers. This lets you do daisy chaining of the receivers. And they have an OLED, so you can see like your IP address, the SD card for standalone mode. They have a Wi-Fi that you can actually use to get to the controller to do some config, and then a real-time clock for standalone mode as well. One more popular, the Culp controllers. These are by Dan Culp. He's one of the X-Lights developers. He has quite a big line here. I didn't get all the pictures in there, but he has some basic 4-port controllers, and all his are based on FPP, and they use either a Beagle Bone or a Pocket Beagle style. And the Pocket Beagle / Beagle Bone uses embedded Linux. It uses FPP, and that's how it drives all the pixels. He kind of has a whole line here. He has a 4-port, an 8-port. Now he has a newer 16-port output called the K16, and then he also has a K32, which has 32 local outputs, but then it has another 16 additional remote. You can run 4 remote cards for another 16 outputs. It supports a full like 1400 pixels per output at 20 frames a second, or about 600 at 440 frames per second. Most of his have a minimum of 2 DMX outputs on the larger ones, and only 1 on his little F4 and the F40. Because they're running FPP, they support the full standalone mode, remote master mode. They have all the software features to run kind of any way you want to do it, bridge. They support the dumb and smart receivers as well. And then they also have OLEDs, USB ports for plugging in additional stuff like Wi-Fi chips, real-time clock. He has also GPIO breakouts, which is like general purpose IO is what that stands for. And that allows you to hook up push buttons and maybe drive a relay if you want to do some more stuff like a donation box. And his newer controllers, the K series, the K16, K32, they also support audio output directly. So there are some other FPP based controllers, not the Culp controllers. The FPP is kind of open source, so anyone can develop them. There's Hanson Electronics over in Australia. They have a breakout board where you can do 16 local ports, and then it has expansion on the top. If you want to get into building your own style controller, there is what I call the PB16 pixel controller, which is the whole intent of it is a kind of a do it yourself. You order all the parts, solder it up, and you can kind of build your own little 16-port controller. It also has an expansion, so you can do 32 outputs as well. and it has a lot of the features of the Culp controller, like OLED, real-time clock, so it can do standalone mode and all the kind of features that FPP supports. So the AlphaPix controllers, these are made by Holiday Coro. They have a line of a 4-port, a 16-port, and then they have their Flex or Evolution system, which can support 3 expansion cards. So it can either do 16, 32, or 48 outputs. The smaller controllers only support about 16 universes. The AlphaPix 16 supports 32, and then the newer Evolution supports 96. You can do about 340 pixels per output on the 16 Evolution. You can do 680 on the AlphaPix 4. Like other ones, they have DMX outputs, and the Evolution supports receivers, the dumb receivers they call them, for doing. So if you get the expansion output that does receivers, you can do those as well to do remote locations. The more advanced kind of controllers sold by Holiday Coro is their HinksPix line. They have the HinksPix Pro, and then they have the Easy Lights / HinksPix 16. The Easy Lights / HinksPix 16, that's just 16 local outputs, and it has DMX. It's the picture on the far right. It's kind of their older controller. They're discontinuing it, so it's still going to be supported from a software aspect, but I don't think the hardware is going to be available. Kind of the future they're going for is the HinksPix Pro, which, similar to the AlphaPix Evolution, has 3 outputs, so you can do up to 48 outputs. But then it also supports 680 pixels per output port. It's got a DMX, and then it also has a standalone mode with an audio, and it has the newer smart and dumb receiver that they're coming out with, that you can daisy chain up to 15 smart receivers together, and it has an OLED SD card, Wi-Fi module, and all the things required for standalone mode. The middle picture is kind of one. That's the controller I have mounted to a stack with a receiver out and a SPI board, or the local output board, on the bottom. Kind of less common in the US. It's actually an Australian-based company. There's the Avitec controllers. They're supported in X-Lights. They have a 4, 16, and then a 16 long range. And they support 96 universes on the larger ones, 25 on the Pixelite 4. Same with most controllers. You can do about 1,000 pixels per output. They have 4 DMX outputs on the 16 and 1 on the 4. And they also have a feature where you can actually use the clock port on the outputs. So you can actually have 32 or 8 outputs if necessary. So you can't really use the power off the port, but you can use the second little output and do your own power injection and actually get 32 outputs out of their 16 port controller. We also have the SanDevice controllers. They're a little bit dated at this point, but they still work pretty well. This is what I used my first year. They only do 12 universes of E131. Hopefully there may be an update to do 16. Jim, the developer of it's been working on that. They have 16 outputs on the larger controller, and he has a smaller 4-port version as well. The pixels for the whole ports is kind of hard to figure out exactly. How it divvies up and drives the 16 ports in banks of 4. It's about 600 per port-ish, so kind of the whole of the controller has to be under about 2,000. You can also use the outputs as DMX, but on the 16, if you use like the grouping, like 1 through 4, if you use one of them, it's DMX, you lose 2, 3, and 4. So it's not the best solution. That's why the 6804 is kind of better if you want a DMX output controller. And there's also a way, the controller by default, at least the 682, also supports DMX differential outputs. There's a little jumper in the top left, but then you have to kind of manually wire the cables to do that differential output. And then we also have these Wi-Fi based ESP pixel stick controllers. They are ESP8266 based normally. They all run the ESP Pixel firmware, which is by Shelby Merrick, Fork and I, if you've seen his username on GitHub. He developed kind of this basic firmware that everyone uses on their boards. It supports E131, DDP, and the ZCPP is all supported in his firmware. The controller itself only has one output, and it can do the full 1000 pixels. And you can also flash a custom version of the firmware onto these and run them as like a DMX bridge, an E131 to DMX bridge. The caveat was that is the hardware has to support it. Like the 3 in the middle, they don't actually support the 2 output pins needed for the DMX, but the official Pixel stick from Shelby actually has it has the plus and minus needed for DMX, so you can actually flash it with the DMX firmware. The design is kind of open sourced, the software hardware, so there's lots of vendors out there that make versions of it, so there's quite a few. You can get them from Shelby himself, or there's lots of people who've made clones or their own versions. So all the controllers I've kind of gone over so far are, they have integration in X-Lights itself. When you do X-Lights, this makes it so you can configure the controller with X-Lights and you don't have to manually put in your universes or your outputs. But how it works is not all of the integration is the same. So some of these controllers, when we upload the settings from X-Lights, they actually have an API, or they have a way that the software can talk to the controller in like kind of its native language. So the more better integration are these controllers that have a API. So the FPP and the Falcon, they have a very good API that we integrate with. The Advtech also, and the ESP Pixel Stick. If it doesn't have an API, what X-Lights has to do is we kind of have to pretend we're a user and press the buttons on the web page. And that can be sometimes hard, and sometimes you'll get fails to upload with these. So you may have to sometimes upload twice for it to work. And those that kind of do this system is the Hinx Pix, the Alpha Pix, the J1 Sys, which is an older controller, and the SAN devices. So if you upload to some of these web-based ones, you'll have more issues. The SAN device is like probably the worst, and we've had some talks with Jim to try to improve it. So maybe in the future it'll get a little bit better, but that's kind of, if you want to have the least hassle with X-Lights, if you go with an API based, it'll have a lot better experience. So when it comes to support with a controller, one thing to think about is like how much support you're going to get from the community. If a controller is more popular, there's going to be a lot more people in the Zoom room or on the Facebook that know how to fix common issues with it. So if you get one of those commonly used controllers, you'll have a lot better luck finding support for free, or just find general support. And what I personally kind of think is important is I would use a controller that one of the developers uses. So out of like the 4 or 5 main developers, they mostly use like Falcon and Culp style controllers. So if if they find a bug in the upload feature, they're probably going to fix it that day, because they don't want to manually configure their controller. They want to use the features that are in X-Lights. So a lot of those controllers have the best integration because all the bugs have been kind of beaten out of them by use of the developers on a daily basis. So I want to talk a little bit about AC controllers. There's kind of lots of options out there. I'm going to touch on kind of the common ones. I'm not going to touch too much on lore because I don't really have much experience, but I know you can do there's lots of lore controllers out there that do AC stuff. The most common types out there is you can either have like DMX based. There's these Renard style controllers that are very like DIY. And then you can have some that take E131 or that take E131 data. So they're similar to like a Pixel controller. And then the newer style thing, like with the Pixel 2 Things boards, it can also take WS like Pixel data and convert it to an AC output. The 2 common types are, they're either relay based, which is the picture on the left, the big blue boxes are relays, and relays don't dim. So it's either just an on or off. So that's more used for controlling like smoke machines or something that you don't want to dim. You just want it on/off. And the dimmable controllers like the Pixel 2 Things and the Renard style controllers, they use what we call triac switching, which will actually dim the lights. So if you have LEDs, old school AC LEDs, it'll dim it by clipping the waveform. So you don't have to understand that too much, but you just kind of know there's a couple different differences. And one of the things, if you try to use a triac with a something that has like a motor, it's not good for the motor. So you normally either have to have a controller that can just go on or off. It doesn't support dimming, or you have to adjust the values you send to it so it only sends a on or off and doesn't have the middle gray value. Like you don't want to send it a middle value and have it in this half on state when you're using like a fog machine. So kind of common ones, you just have your standard DMX. You have like your lower boxes that can run in a DMX mode, and you can control AC. You can get just a DMX controller off of Amazon or eBay. There's kind of lots of them out there. And Holiday Coral also sells one. Normally they can be daisy chained together. You can run them off of like a Pixel controller, and most DMX outputs on Pixel controllers can do 512 channels per output. So you could daisy chain, if you have a 16 output DMX, you could daisy chain like 30 or however together to fill that whole space. More popular recently, the Pixel to Thing boards. This takes pixel data or WS281112 data and converts it to like these AC or DC outputs, and they also then can change the data back into DMX as well. So you can use these to drive motors, animatronics, things like that, and just run it off of your pixel data. So, and then there's a couple of controllers made by Holiday Coral that actually take like E131 and then convert it to AC. So this would kind of be like a pixel controller. You give it one E131 out universe, and you can control 16 or 24 outputs with a dedicated controller, and you don't have to run it off of another controller. If you want to be a little bit more DIY, there's also Renard controllers, which is kind of, you have to solder them yourself. They have two basic styles. They have controllers that have the dimming capability or the triacs right on the controller. That's the left. So you just hook up your AC right to it, and you would send the data to it. And then they also have kind of like this remote configuration where you can plug in different triac boards to it and do this and have them distributed throughout your yard. And that's what the picture on the right is, where you have the RJ45 jacks then going to a driver board. Like I said, it's kind of all DIY, solder yourself. Most of the people out there don't sell fully populated controllers. You have to buy all the parts and build it. So that's kind of the crux of everything I have. If you have any questions, I'll try to go through the chat here, or you can open up your mic and I'll try to answer them the best I can.
Yeah, I'll unmute everybody so you, or give you the option to unmute yourself if you want to. So if you want to either type in chat, or Scott, you can go through the chat list, and if anyone else wants to jump in on audio, you can now.
Okay, here.
Hey, Scott, can you hear me?
Yep.
Hey, quick question. Will the presentations be available somewhere to download and view later?
Yeah, so hopefully later today, once I'm done with all this, I'm going to put them on my website. So that's a scottnation.com. I have a page called X-Lights Presentations, and I have all the presentations I've ever done on there. So I'll hopefully upload them there later today or maybe tomorrow.
So there's not going to be a single repository for all the presenters to put it?
I guess we might need to talk to Ed about that. I'm sure that is possible. We could put them all on the website eventually. So.
Well, that would be wonderful. Thank you, sir.
Mm-hmm. There's some questions about mixing controllers. Yeah, if they're all E131, you can mix and match them. There's no real big deal there. Pixel outputs at 20 frames per second to 40. So basically, if you know the underlying like pixel protocol, it's a clocked signal output, and it's at 800 kilohertz a second. So in theory, you have to clock out all of the individual channel data to that all your pixels on a string. And at 20 frames a second, you can only do about 1400 pixels before you then hit the next frame. So the max of any controller at 20 frames per second is always going to be around that 1400 mark. So if you, because it's physically like, you know, at 20 frames a second, you can't clock out the data fast enough. So when you go to 40 frames a second, you have half that time. So now you can only do about 680 clocked pixels before you hit the next frame. So that's kind of the difference there. When you go to 40 frames, it's only about 600.
Yeah, Scott, just a question there on that very question. Do you find that you can hit that limit with most controllers? Because you know, the time it takes to get in the E131 does that go in parallel with say the other part of the microcontroller clocking out the data and so on?
Yeah, so that's what that's kind of a little bit of the unicast versus multicast. If you do multicast, you don't need to get a confirmation back when the packet is sent over the network. So it's you have less of a delay. When you have unicast, it's actually a bidirectional connection. Sorry, I'm not a huge networking expert, but and it is normally pretty fast. That's why kind of the common thing is if you're doing sequences to actually always be a little bit ahead, because in theory the data is going to be within that one frame, that 50 milliseconds, so it'll be it'll be pretty close, but it's not going to be exactly. It's not going to be like as soon as you click the output from FPP, it's going to be on your controller. There is some propagation delay there, but to keep up with the 20 frames, that's kind of why they use that 600 number. Like I personally try to keep all counts under like 300 because I don't want to push. And when you start doing like 600 per output, if you have like the second pixel die, then you're going to have 600 other pixels that don't work, and it's going to look kind of dumb. So that's why I like to keep my outputs under a couple hundred to kind of prop it, so I don't have that issue.
I think that's great advice. Keep it under 300. You're pretty sure to hit whatever rates you want then.
Yeah, that's what I've seen people like run a whole megatree off of a port, but I've had experiences at minis where someone said the third pixel died and then their whole megatree is down. So it's kind of a little bit of a, you know, well, it looks stupid if one string's down, yeah, but maybe it'll look better than no tree. I don't know. It's kind of what you think is better.
Yeah, I think you can afford to lose one string in a mega tree, but you know, no more than one string.
Mm-hmm.
Yeah, good. Thanks.
Mm-hmm.
Good talk. Very informative. Thanks.
Thank you.
Scott, you had mentioned about mixing boards in displays. Getting a little more granular on that, can you mix boards on, let's say, a megatree and expect it to look as it should?
I guess at the end of the day, like as long as the controller's not changing settings, the data should be the same.
So, I mean, for example, you've got half the tree is a SAN devices and half the tree is an alpha pix.
Mm-hmm. So if you don't change, like in your controller, you can change like brightness, gamma. If you don't change any of those settings, in theory, the data coming out of FPP is going to be the same as what's on the controller. I do know like SAN device doesn't support the ranges of brightness like a Falcon does. So if you tried to run at 20% brightness, the controller is going to take, so when you have like a data coming out of your sequence, every pixel is a 0 to 255 value. That's the three colors. So when you do 20%, it's going to take that 0 to 255 value and do 20% of it. Well, then if you have a SAN device and it only does 25%, then in theory, those numbers are not going to be the same. So that's why, and from an X-Lights standpoint, it's really a pain to have one prop with two controllers on it. So if you're going really large and that's something you have to deal with, I would kind of keep common controllers, but you can in theory do it. It might take some tweaking to make it look just right, or you may have to pick a common brightness and go from there.
And would it work better if you set the brightness in X-Lights as opposed to try to set it at the controller?
I'm personally not a huge fan of that. I like doing it at the controller. So Yeah, like sometimes you have to do that. Like if you run DMX or Renard stuff, they don't really support brightness at the controller. So then you have to play with value. You have to play with the brightness curves in X lights. But I like to do it on the controller because then I don't have to re-render sequences. So yeah, I think if possible, I would avoid different controllers on the same model, but I'm sure there's ways around it.
Okay. All right. Thanks.
I've got a question here, Scott, about the Falcon controllers.
Uh-huh.
So I watched Jeff Lacey's video that he made a few years ago on the Falcon F16 V3, just doing like a quick overview. And he mentioned some features in there like an audio board direct from the controller and some like analog trigger inputs. Do you know what's the support on those right now? I don't know what state the firmware is in.
So in 2.55, which is the newest, it supports standalone mode with audio output. Those audio boards, Dave Pitts doesn't sell directly on his website, but if you email him, he does have a limited supply that I do believe he'll sell to people. And for the triggers, yes, you can use, I think it's the A-in ports. There's like 3 of them at the top. And you can actually send, I don't remember if it's ArtNet commands, but you can actually then trigger, like if you had a button, you could send a command back to X schedule or back to FPP to do something. So there's a way to do it. I'm not a huge expert on that. I have done the events in like FPP where you can do more advanced stuff. But yeah, the newer firmware does support a lot of that out of the box.
Okay, and who would I try to talk to again to get one of those limited audio boards?
You'd have to talk to Falcon is made by David Pitts directly. He has his email and his contact on his website. If you go to Pixel Controllers, I think it's .com, they'd have all that.
Okay, thank you.
Yeah, I do see a comment about the Ron P controllers. I did think about putting those in my presentation. If anyone doesn't know, Ron P, he makes kind of an open source FPGA based controller. You basically buy the parts, the FPGA and Ethernet cards off of AliExpress, and you can kind of control lots of pixels. I don't think he does fused outputs on his. It's all just pixel data output. And there is no configuration on the controller. You have to, it's all multicast, and you have to set up the universes kind of in X-Lights a specific way. I do know it's a rather cheap way to go. I think his controllers are like $40 to $60, but there is a lot of, it's very DIY, kind of hard to do for a real intro person. But I have looked into those a little bit before, if anyone is interested in those.
That's just to add to that, Scott, that's a good, I was going to ask was how active is the open source, open hardware kind of scene with regard to controllers? I'm running a Mega 3 with a fused 16 channel output I developed myself based on ESP32 and Orange Pi. It's working quite well. Just wondering if there's anybody else kind of developing, doing the same kind of stuff.
Yeah, so I know like that was a huge thing early on in the, but then a lot of Chinese clones or people start cloning each other. That's why I didn't want to self-promote too much, but last year I started doing a Pocket Beagle based controller. I call it the PB16. I had a link in there, and I made the design in KiCad and I released it, all the Gerbers and everything, so you can kind of build your own boards if you'd like. And that's what I run a lot of my show. So you can order the raw PCBs from a place in China, get the parts from a BOM, AliExpress, or I get most of mine from DigiKey in the US here. And you can kind of build up a board, and if there's features you don't want, like you don't want serial, just don't populate those parts, and you can kind of make a cheaper controller. I have a BOM for what I call like the cheapest controller that doesn't have all the extra features, and it's about $80 a board. And you can make a basic 16-port pixel controller that runs FPP and drive your lights with that.
Great.
So
I'll definitely look into that. That's kind of my area, is kind of DIY building. I make PCBs at home, that kind of thing. So that would be really interesting to me.
yeah, I did play around with the ESP32 to do like an 8-port controller for a while, but I was having a lot of problems with the E131 locking up the Wi-Fi side of it. And I'm not a huge fan of Wi-Fi in general in a show, so I wanted more Ethernet based.
Yeah.
I know there are some people experimenting with the new like Teensy 4.1 to see if they can make an open source controller or make something, a basic controller using the newer Teensy as a rather powerful chip on it. So
Yeah. Cool.
we have a question about limitation of universes per controller. So universes per like your show, if you're going to do a whole show, your limitation is basically your network at that point. There are people who do like drive-throughs and they have a gigabit Ethernet backbone and they'll run, I don't know, millions of channels. So I don't know, that's hundreds of thousands of universes. On FPP, I know once you start getting to like the 2 million, it starts to slow down. So that's why a more master remote with FPP is a little bit better. But like the drive-through Arizona, some of those bigger shows, they run a laptop with a gigabit Ethernet. They run X schedule and they'll run gigabit switches for the most part, and then they run Falcons at the end because Falcon only supports 10100, but they try to keep the main backbone as a gig. And yeah, the Arizona I think is like 2 million channels. So Falcon and Culp pros and cons. I see that a lot. I personally think Falcon is like, if you want the easiest controller to take out of your box and get set up in your yard in a half hour, I think the Falcon is like second to none there. It's you can easily put a Falcon, put an IP address in it, plug it into your computer, get it running in a half hour. It's a little bit more expensive, but I think it's a more better system. The Culp, I personally do like the BeagleBone or FPP based controllers, but I have a background in electrical engineering and IT and stuff, so I'm not scared of the kind of complications of FPP and all that. So that's why I kind of talked about technical ability. If you already think this hobby is kind of crazy because of the networking, a Culp or something more, you have to do more IP based bridging and stuff. That might not be for you, and maybe a Falcon is a simpler solution. But so it all kind of depends on your own technical ability, and if you want to go if you have a networking background and you're into that stuff, the Culp and the FPP based controllers I think are great solutions, especially for their cost. How many pixels do you want to run in a show at 40 frames? So if you're running at 40 frames a second, you can only do about 600 pixels per port. So I personally, like I said before, I only do about 300, so I don't ever get near that number. So there is a little bit. That's why like it's closer to 1,000, 1,400 if you're at 20 frames a second. But if you're doing 40, it's 680, I think is the official number that most people use. Is there a problem with running FPP Culp boards in a F16? No, it's basically you can run a Culp in a master remote, or it can run as an E131 bridge, and then you could run an F16 as as the E131. Software alternatives to FPP. If you want to just run like a master, if you want just a show player software alternative to FPP is X schedule, yeah. Someone wants to run Arduino. Yeah, there is some code out there to run Arduino if you want to make your own like little one-port E131. If you go to like the DIY Christmas forums, there's lots of guys who have some code out there. Wireless versus wired. If you're doing a large show, I think wireless is kind of a joke. There used to be like on the second season Christmas Light Fight, some guy said he used like 100 ESP pixel sticks. I don't know how he would have ever got that working. If you want to do wireless, I think it has a place like for an indoor Christmas tree. I think it works great for small one-off props, but if you're going to try to run 100 props off ESP pixel sticks, that seems like a real pain to me, but it's kind of to each his own. If you want to attempt it, I'm sure there's ways you can get it going. Yeah, I see the WLED. I know that's popular because of Dr. Z's. He was promoting it. It's not really natively supported in Xlights to upload to it. I did talk to the creator of WLED for a little while to try to add support and add better like JSON interface so we could do some of that stuff. And I don't know if he's added it yet, but.
Hey, can I jump in and ask a question?
Sure.
So the wireless versus wired, if I'm running matrices that are BeagleBone black, you know, and FPP's on the BeagleBone, everything is like executing from the BeagleBone. So it's like initiated from the master, right?
Yeah. So if you're doing, like a master remote over Wi-Fi, I think that's fine. That's what Dan Culp, who runs the Culp boards, that's what he does. He does all of his are master remote over Wi-Fi.
Okay.
I've actually thought about doing that myself, like just putting Wi-Fi chips on all of them, but I don't know if I really want to put up a Wi-Fi access point in my front yard. But yeah, but I like sending the E131 over Wi-Fi is where you can start getting lag, and that's
Right,
where
okay.
the ESPs where I think they are kind of limited.
Okay, cool. Thanks.
I ran a Megatree with 16 strips last year with 4 ESP32 pixel strips and what do you call them? The ESP 8266s. And it worked surprisingly well, but the access point was only 20 feet from the tree. But this year I'm going Ethernet. So
yeah, I know if you watched the Dr. Z's videos, he was huge on the ESP pixel stick kind of type thing, so that became real popular. I think you can do it up to a point, but once you start getting a certain size, I think it's going to get unwieldy trying to have all those separate controllers and everything.
yeah, agreed.
Okay, we're coming up on the last 10 minutes. Scott, if there's any further questions, we've got a little bit of time left to do a few more questions, and then just make sure we leave some time for the raffle at the end.
Yeah, there's some questions about like how do I program a show. I see. I think you really want to go into the beginner room and see like Keith Wesley's presentation that should be coming up soon. Or I know there's an RGB Basics by Ken Spader Christmas. He gives you some real good background on how you can get started in this. So. That's what I see. Yeah, just people commenting about switching from art sticks to Culp boards. I hope that's everything. Yeah, I don't know. Here's kind of our sponsors. If you can promote the sponsors, go buy stuff from them. They gave a lot of stuff to this today, this whole weekend. If you can buy from them, kind of support them, support the people who support us and support this. I was on the team that kind of helped put this all together, and there's some of these people put in a lot of hours to get this going. So try to promote that. So I don't know, Brian, do I have to stop sharing or how you want to do this for the awards?
If you can stop sharing, I'll share my the prize calculator sheet.
Okay.
All right, give me a sec. Let's do. There we go. Okay. All right. So as we mentioned at the beginning of the session, you need to be present to win. So I captured all the VCS IDs of the folks who were in attendance earlier on in the session. And we're going to run down the list. So we've already got it all entered in here. And for this session, we've got 2 prizes. One, which is a mounting kit system from JDation, and a $25 gift certificate from Cool Tees Custom Apparel. So hang tight here. Another thing just to mention is that the rules this year are that you can only win 1 prize during the course of the entire session. So if you've already won a prize, you'll be ineligible. And then a runner-up, which is listed in the list here, will win the prize. So that's why we've got so many runners up here. There's quite a few prizes to go around, so likely we'll have to start circulating through those in the later part of the session. So here we go. Let's see what we get? All right. We have first one is the mounting kit system. We have ID 1319. Mike Connolly, are you here? Let's list the participants. 1319. Doesn't look like he is. 1319. I do not see him. Oh, there, he's here. Okay, so Mike Connolly, you are it for the JDation mounting kit. All right, so I'll get your ID here in just a second. And next item is the Cool Tees Custom Apparel $25 gift certificate for ID 2136, Barry White and Zachary. Let's check 2136. 2136, Barry White is on. So both of you two gentlemen, you will win. So just bear in mind, if there is a potential or if you've already won an award, we'll be picking from the runner-up list. But congratulations to you, and we'll be in contact soon about your award. All right, stand by. Okay, here we go. So format for, oops, stand by. The remainder of the session here,